welcome back to another edition of In the Cosmos from the De Anza College Planetarium. As always, I'm your host, Toshi Komatsu, and the director of the planetarium. Now, in our last video, we looked at how the barely elliptical orbit of the Earth around the Sun is actually not the reason for the seasons. In fact, we learned that the Earth is actually closer to the Sun in the wintertime and further away from the Sun in the summertime. Now, another thing that an elliptical orbit does not explain is why the days are shorter in the winter and longer in the summer. So let's go ahead and take a look and find out why that is. Here at De Anza College in California, it's still winter. The days are short, although sunset is slowly creeping later and later. Now, we backed up here to December 21st, 2020, and this date is the solstice. It's the shortest day of the year. And how short is it? Well, we're starting here at sunrise. You can see the sun peeking above the horizon here in the southeastern part of the sky here. And we're going to go ahead and skip ahead 1 hour at a time and watch the path that the sun takes. So we start off at sunset going 1, 2, 3, 4, 5 hours until it gets close to this green line here called the meridian. Now, notice also that the sun is crossing quite low on the meridian here. If I turn on a little grid here, each of these horizontal lines here notes about 10 degrees. And so we're at about 20 to 30 degrees above the horizon along the meridian here. Now, this meridian line actually runs due north-south, and the sun reaches its highest point in the sky when it reaches this meridian, and that's what we call noontime. So it's literally the dividing line between the morning when the sun is coming up, and sometimes we might say that's before or the anti-meridian, and the boundary between when the sun starts going down or after or post meridian. And this is actually where we get the terms AM for anti-meridian and PM for post-meridian. Now, on this date, again, it only takes 5 hours to get from sunrise to noon, and it'll take another 5 hours, counting ahead to 1, 2, 3, 4, 5, a total of 10 hours in the wintertime of daylight. Now we've jumped to March 21st at sunrise, and this is the equinox date. And let's see how long it takes for the sun to take across the sky this time. So we'll skip ahead 1, 2, 3, 4, 5, 6 hours to get to noontime. If I bring up my grid, again, you can notice here that the sun is actually crossing much higher along the horizon than we just saw in the wintertime here. We paused at 6 and we'll count another 1, 2, 3, 4, 5, 6 hours until sunset. So we've got a total of 12 hours. And in fact, the word equinox literally means equal night, meaning there are equal hours of day and night. So now we've jumped to June 21st at sunrise, and this is the other solstice. And on this date, it takes the sun 1, 2, 3, 4, 5, 6, 7 hours to get to noon. And again, if we bring up our trusty grid here, we'll see that the sun is crossing at about 70 degrees up above the horizon along the meridian. So this is much higher than what we saw in the wintertime here. We paused at 7 here. Let's go ahead and keep counting the number of hours that the sun is in the sky. So we stopped at 7 and we count 8, 9, 10, 11, 12, 13, 14, and we'll call it 15 to get the sun to actually set there. So it's between 14 and 15 hours in the summer. So the reason why days are longer or shorter is because the sun is actually appearing to take longer or shorter paths in the sky. We just saw the sun take a long, high path here in the summertime. And remember, in the wintertime, we saw the sun start off quite low here, and it took a very low, short path across the sky, again, in the wintertime. So why does the sun do this? Well, there's no way to explain this behavior with an elliptical orbit. Being closer or further to the sun doesn't change the angle of the path of the sun. What does change the angle is the tilt of Earth. And that is the reason for the seasons. And we'll talk more about the tilt in the final part of our series. As always, if you enjoyed this video, please do like, subscribe, and share the video with others. And do check out our website and all of our social media. The links for all of that is in the description below. For now, we'd like to thank you for checking in, and we're wishing you clear, dark skies. And for now, this is the De Anza College Planetarium signing off.